Hello everyone, the topic of this presentation is the electromagnetic spectrum. All waves have three properties: wavelength, amplitude, and frequency. Before defining these terms, let's look at a sample wave. Here we see a typical wave. Note that the maximum point of the wave is known as the crest. The minimum point is known as the trough. In addition, there is an imaginary midline drawn through the wave. This midline is equidistant from the crest and from the trough. Wavelength is literally the length of one wave. It is represented by the Greek letter lambda and is measured from crest to crest or from trough to trough. Amplitude, represented by the capital letter A, is half the distance from crest to trough. It can be measured from midline to crest or from midline to trough. The distance from crest to trough therefore represents two amplitudes. Frequency, represented by the Greek letter nu, measures the number of waves passing a given point per unit time. It is measured in waves or cycles per second. This unit is known as the hertz. Here we see a low-frequency wave. If this illustration captures the motion of this wave over a time period of 1 second, then 2 waves pass per second. The frequency of this wave would therefore be 2 waves per second, or 2 hertz. This is a high-frequency wave. Again, if 1 second has elapsed in this illustration, then 6.5 waves pass per second. The frequency of this wave would therefore be 6.5 hertz. Juxtaposing the two waves reveals an important relationship between frequency and wavelength. Note that as the wavelength becomes longer, the frequency of the wave decreases. Similarly, as the wavelength shortens, the wave's frequency increases. Now, let's turn our attention to the specific form of energy known as electromagnetic radiation. This is a form of energy that travels through a vacuum at the speed of light and includes 7 types of radiation as listed here. Electromagnetic radiation is so called because it includes 2 types of waves traveling simultaneously at right angles to one another. One wave is electrical, while the other is magnetic, hence the term electromagnetic radiation, or EMR for short. It turns out that, when measured in the correct units, wavelength and frequency are inversely proportional. That is, wavelength and frequency will change in opposite directions, so that their product is always the same, the speed of light in a vacuum. Note that the product of wavelength and frequency in each example presented in this slide is the speed of light in meters per second. There is a second mathematical relationship characteristic of waves. Recall that energy is the ability to make something happen. Take a look at these 2 waves. Which one looks like it's higher energy? If you chose the wave on the right, you are correct. In fact, a scientist by the name of Max Planck demonstrated that, when measured in the appropriate units, a wave's energy and frequency are directly proportional. In other words, wavelength and energy increase or decrease at exactly the same rate. As a result, their quotient is constant. That value is known as Planck's constant. Recall that EMR consists of 7 different types of radiation. Each of these types has a characteristic range of wavelengths, varying from more than the length of a football field to less than the width of an atom's nucleus. We can use wavelength to organize these 7 types from longest wavelength to shortest, as shown in this diagram. What results is known as the electromagnetic spectrum. Recall that the wavelength and frequency of EMR are inversely proportional. Therefore, if the electromagnetic spectrum proceeds from longest wavelength to shortest, then it also proceeds from lowest frequency to highest. And since frequency and energy are directly proportional, the spectrum also proceeds from lowest energy to highest. Let's examine each form of EMR individually. Radio waves are the lowest energy form of EMR. Note that as wavelength shortens, frequency increases from AM waves measured in kilohertz to FM waves measured in megahertz. Lower energy microwaves are used by cell phones, while higher energy microwaves are used in microwave ovens. And since these are different portions of the spectrum, no, cell phones can't cook your brain. The prefix infra means below. Infrared radiation, or heat, is below red light in terms of energy. IR is used in a variety of applications. It transmits information from remotes to the device being controlled. It's also used to create images based on temperature differences. By the way, the IR radiation emitted by heat lamps is not visible to humans, so manufacturers include emissions from the red-orange segment of the visible spectrum so you can tell the lamp is on. Otherwise, owie, owie, owie. By the way, poisonous snakes known as pit vipers have so-called pits that are sensitive to IR radiation and are therefore used to track prey. The visible light spectrum colors are also known by the mnemonic Roy G. Biv. The red end of the spectrum is lowest in energy, that is, longest in wavelength, while violet is highest in energy, shortest in wavelength. Incandescent light bulbs emit the entire visible spectrum, so we see their light as white in color. The prefix ultra means beyond. Ultraviolet radiation is beyond or above violet light in terms of energy. UV radiation has 3 bands, A, B, and C, and all 3 types are emitted by the sun. The lowest energy band, UVA, ages skin upon exposure, while the higher energy band, UVB, burns skin. And yes, the UV radiation emitted in tanning booths has the same wavelength range and therefore causes the same type of damage. In fact, excessive exposure to UV radiation can cause melanoma, a potentially lethal form of cancer. Using sunscreens can protect your skin from both UVA and UVB. UVC radiation is lethal and is entirely reflected back to space by Earth's atmosphere. By the way, bees can see color in the UV portion of the electromagnetic spectrum. X-rays are still higher in energy and therefore even more dangerous to cells. We can use short controlled exposure to X-rays to produce images used in dentistry and medicine. CT and CAT scans take multiple X-ray images while rotating around the body to produce 2D and 3D medical images. Gamma rays are the highest energy form of EMR and therefore the most dangerous. They are emitted by radioactive decay and other types of nuclear reactions. Gamma knife surgery is a medical treatment that uses short controlled exposure to gamma rays to destroy cancer cells. Ionizing radiation is so called because it has enough energy to remove electrons from atoms, thus creating cations. When ionizing radiation penetrates cells and ionizes DNA, mutations can result. The right combination of mutations can result in uncontrolled mitosis, that is, cancer. If the mutations occur in developing fetal tissue, birth defects can result. There are in fact 2 types of ionizing radiation, high-energy EMR and particles emitted by nuclear decay. Ionizing EMR includes ultraviolet radiation, X-rays, and gamma rays. Non-ionizing radiation includes radio waves, microwaves, infrared, and visible light. Speaking of IR, this seems like a good time to learn about the properties and applications of infrared radiation in detail. When you exit the screencast, proceed to the next slide. Wait, and the slide after that, because you don't want to miss the video that reviews the properties and applications of all the various types of EMR. Thanks for watching.